In the late 18th century, Pierre-Simon Marcus de Laplace was one of the first scientists to discover that a chunk of matter could be compressed to the point at which its surface gravity could prevent the escape of light. He is known as one of the greatest scientists of all time. Based on Einstein's theory of relativity, Karl Schwarzschild, a German physicist, adopted and developed the concept of black holes in 1916 and accredited the theory. 1968, the American physicist John Wheeler contributed a large amount of research to our now accepted understanding of black holes. Our universe is full of stars. At the end of their lives, some die quietly, others create a magnificent explosion, and others give birth to black holes. When massive stars 10 times heavier and larger than our sun die, gravity crushes them, creating a huge explosion, the supernova. But some stars are even bigger than that. These supermassive stars weigh 100 times more than our sun, and it has 100 times more gravity. If one of these stars dies, it sets off the biggest explosion in the universe, the hypernova. The birth of the black hole occurs. This is an example of a dying star, a billion miles across. Like all stars, it is a huge nuclear fusion reactor, pumping energy outward. At the same time, the star's extreme gravity crushes inward. For a few million years, fusion and gravity balance each other, because gravity doesn't let the fusion escape. When the star finally runs out of fuel, the fusion stops, and the gravity wins in less than a second. The core shrinks to a fraction from its original size, and a black hole is born. At this moment, the black hole sucks up the remaining of the star. The new black hole in the middle consumes the debris around the star. It consumes the gases so fast that it finally explodes, blasting out energy. The star explodes in less than 1 second. It explodes out 100 times more energy than our sun will ever produce. What is left is a new black hole. The black hole's gravity is so strong that it sucks in all surrounding substances, including gases, stars, and galaxies. In the center of every galaxy, there is a massive black hole. The black hole is what keeps the galaxy intact due to its gravitational force. Therefore, it is essential for any galaxy's formation, as it collects the stars together to form what we call an independent galaxy. In Geneva, Switzerland, the European Organization for Nuclear Research, CERN, the Large Hadron Collider, LHC, the world's largest and most powerful particle accelerator, was built. It was a topic of dispute and global interest, even leading to many court cases due to the high-energy experiments, which was able to produce the first micro-black hole on Earth. People feared that the creation of the black hole could suck up the entire Earth. CERN responded to these fears by explaining that their experiments took all necessary safety precautions and that the miniature black holes are of no threat, according to the theory of Hawking radiation. Black holes lose mass because they emit Hawking radiations. Black holes which lose more matter than they gain are expected to shrink and ultimately vanish. The existence of Hawking radiation theory has not yet been observed. A theoretical dispute exists until today.